Hello and welcome to section 5.2 about composition and decomposition of functions. So what does function composition mean? Well, it means plugging the output of one function into the input of another function. And we're going to see what that means in practice. It might not be clear why this is useful, just reading the sentence here, but it is a really important concept in math and a lot of math related things. So, anyways, let's look at example one here for an example of function composition. So let's suppose that t is the year. So for example, right now t equals 2020. And we have that a town starts with population P equals 1,600 people in the year 2000 and grows at a rate of 100 people per year. So let's look at a fairly simple function. F of t equals t minus 2000. And there's a typo here when I wrote it. I wrote 2000 minus t. That should be t minus 2000, so you can fix that. So the question is, what does this function represent? What does it tell you about the town and the year? Well, let's just try some values really quick. If you do f of, I don't know, 2005, I'm just going to pick a year, you're going to get 2005 minus 2000 is 5. If you do f of 2013, you're going to get 2013 minus 2000 is 13. And that 5 represents how many years it has been since the year 2000, in that year 2005. So, in other words, f of t, the output of this is like the 13 or the 5, is the number of years after 2000 in year t. Okay, so let's look at this other function. G of x equals 100 times x. So it's another fairly simple function, but then we're going to get into this messy notation here. What does g of f of t represent? Well, first of all, let's just try to match up these parentheses so it doesn't look like just a confusing mess of symbols here. This parentheses here goes along with the one on the outside here. So the input into G is f of t, is what it's saying. So to do G of f of t, what that means is I'm going to take the x here, the input into G, and that x is going to be f of t. But what is f of t? F of t is t minus 2000. So g of f of t is going to be 100 times the input into G. And that input into G here is f of t, and f of t is t minus 2000. So that's what I'm going to replace this x with. So instead of doing 100 times x, we're doing 100 times t minus 2000. So this is an example of function composition here. We're taking the output of the function f. The output of the function f is the result of like t minus 2000, and making that be the input into the function g. Okay, so what does this mean? Well, let's see. If you're going to do g of f of 2005, for example, so remember t is a year, so I'm just replacing t in this expression with a year such as 2005. What this says is going to be 100 times 2005 minus 2000. And 2000. There we go. And 2005 minus 2000 is 5. So this is going to result in 100 times 5. Now that 5, remember, is the output of f of 2005. So, and that is how many years it is after 2000 in the year 2005. So we do 100 times that 5 years since 2000. And what does that say about the situation? Well, it says it's growing at a rate, the population of the town is growing at a rate of 100 people per year. This means 100 people per year times 5 years that have passed since 2000. And it's going to be 500. So that is the amount of growth in the town after 5 years. Or in other words, in the year 2005, the growth in the town is going to be 500 people. So in general, g of f of t gives the growth in the population of the town in year t. From 2000 to year t. Okay, so let's look at this other function. H of x equals 1600 plus x. And we want to find a formula for this monstrosity. So let's try to match up the parentheses here. F of t is the inside. So the parentheses around t match up. Then there's the parentheses that denote the input into g. That's those ones. And then there's the parentheses on the outside that denote the input into h, is the way these should match up. So what we're saying is we're going to take the year, t, and plug it into f and get that output. And that output is going to be the number of years after 2000 that year t is. And so you take the number of years after 2000, and g of that number of years is going to give you the growth in the population that has happened from 2000 to year t. And then what h is going to do, well, it's going to take the growth in the population and plug that into x here. And it's going to do 1600 plus that growth. So let's get a formula for it and then use an example of plugging in a value of t to make sure we understand what it's doing. So first thing I'm going to do is, I already know what g of f of t is. G of f of t is this thing right here. 100 times the quantity t minus 2000. So that's what we're talking about here. So I'm going to take this part and write that as h of 100 times t minus 2000. That's g of f of t. Okay, now that is now going to become the input. This whole thing here that I'm going to highlight in green is now the input in place of x. So the formula tells you that what does the function h do? It takes the input and does 1600 plus that input. So in this case here, this is going to be 1600 plus 100 times t minus 2000, like so. And so this is the formula for h of g of f of t. So here's the f of t part, here's the g of f of t part, And then when you do 1600 plus that, you have the whole shebang, h of g of f of t. So what does this do? Let's take an example. Let's do h of g of f of 2005. And this example will help you understand what the function really does. This is a good thing for understanding functions in general, is try a specific number for t, for whatever the input is, and see what the function does with it. So we got this formula here. We're going to do 1600 plus 100 times 2005 minus 2000. And the 2005 minus 2000 is just 5. So this is going to give you 1600 plus 100 times 5. So that 5 is the years after 2000 that 2005 is. It's 5 years later. And it's growing by 100 people per year since 2000. So it's 100 times 5 years is the number of people that is growing by. That's 500. And then we're doing 1600 plus 500 comes out to be 2100. So that is going to be, the 1600 was the starting population in the year 2000 plus the growth in the population from 2000 to year 2005 is that plus 500. So that's what the population is in the year 2005. And so this is a really good example of function composition. We're taking three functions that are fairly simple on their own, and it kind of makes sense what they do on their own, but when you put them all together, you can make a more complicated function. This is a fundamental concept not only in math, but also in computer programming, and any kind of thing that uses math, putting expressions or functions together to make more complicated ones is a key idea. Okay, so let's look at example 2. So we have that oil is leaking out of a damaged oil tanker. Oh no. The radius of the circular oil slick is r equals f of t equals 300 times t meters after t hours. And we also know that the area of a circle with radius r is given by this function. A is the output variable, g is the name of the function, r is the input variable. So you plug in the radius into this formula and you square it and multiply it by pi, and the result, the output, is the area of that circle. So what is the area of the oil slick after 5 hours? Let's do part A here. So after 5 hours, that 5 here is the number of hours that we're talking about. And so we can find what the radius is at that point. The radius is going to be f of 5, and that will be 300 times 5, which is 1,500 meters. So that's the radius after 5 hours. Once you know the radius at that point, we can find the area. So the area is going to be the result of the function g, but when you plug in the radius of 1,500 meters. Right, and 1,500 squared is a pretty big number. Better get out a calculator for that. Actually, let me use this calculator. I'm going to do pi. This isn't working. Hang on a second. Alright, so if you do pi times 1,500 squared, you'll get 7,068,583. Square meters is the result of that. So Now, so what we did here is we took the output of one function, the 1500, and made that the input into the other function, g, and then got that result. So this is an example of function composition. So now, what if you want to find a formula for a in terms of t? So that means we want to get something that looks like a equals some kind of messy formula where you do some math where t is involved in it. But what is all of this math that you do with the t? So how do we do that? Well, we're going to do the same principle as the last example 1. And it's going to be the same idea as what we did here with the specific number, which is take the output of one function. I'm going to take the f of t output, and I'm going to make that be the input into the other function. So we want to get the a, and I'm going to take the function g. The function g here is a function that outputs area. But we don't want it to be in terms of r, we want it to be in terms of t. So the input into this is still going to be the radius, but I'm not going to write it as just r, I'm going to write it as f of t. That's the output of the function f of t, which gives you the radius. So that is going to just be g of 300 times t. And so whatever that comes out to be for a particular t, the function says to do pi times that squared. So we're going to do pi times 300t squared. And 300 squared gives you 90,000. So you could write this as 90,000 times pi t squared. And let's just check that that does the same thing as what we got before. I should be able to plug in t equals 5 into this and get, so we're going to do 90,000, and sorry, plug in t equals 5 and get the same 7,068,000 answer. And yep, it gives you the same thing. All right, so that's function composition. If you're not very good with function notation, this is going to be a tough section, but it's also a good section to go back and really get a better handle on function composition. It's a good place to go and talk to a tutor about it, because this is something that it's a more conceptual section and less about calculating stuff. And it's the kind of thing that it helps to talk about with somebody. So if you want to talk to the tutor in their office hours, that would help, or come to my office hours and we can talk about some of these problems. Up next, you have an exercise to do, so I'll show you that in the next video.